Hello and welcome back to FPV Reviews. Today we're going to be looking on the bench at the Reptile Dragon 2. The Reptile Dragon 2 is I love that how they spell tail here with an E on the end. Very cute. They call it the double tail version because it comes with two different interchangeable tails. Now in this manual they call the conventional tail, they actually call it a inverted T-tail. A T-tail is this. Now this is not a T-tail at all. This is just simply a conventional tail. The other tail that comes with is the V-tail. Now the V-tail could be attractive for a number of reasons. A lot of people like the way it looks. They've talked about the way it looks, but one of the advantages that it has is that because there's no horizontal stabilizer per se sticking out toward the sides upon landing, or even during takeoff when you're throwing the airplane, the tail will be up more away from the ground and away from your hand when you're hand launching. So. And there's some other advantages to it, perhaps a reduction in drag. There's also some maybe negative aspects to having a T-tail, or I'm sorry, a V-tail. So a lot of people use the conventional tail instead, but we'll be experimenting with that. But it comes with both, so you can try out both tails. Now, in this episode, we're going to be looking not only as a review and like what you get when you buy it, but we're going to be taking a little more in-depth look at some of the aerodynamic concepts, the structural concepts, and implementation that were used in the design process of this aircraft. Now, we've seen a lot of airplanes meant for FPV and autonomous flying lately in the last year or two that are about the same size, this 1200 millimeter size, and an increasing amount of them have quite a large wing chord. So they have a kind of not very great aspect ratio because they don't have a very big span, but they do have a large chord. Obviously they're trying to get a larger wing area to kind of give you a larger airplane for the size, and while still keeping it portable for transport. And this one actually breaks down quite a bit into sections for transport. Now this can have some negative effects for efficiency, and we'll go in and talk about that a little bit later. But there's also some positive things about this general concept, and we'll discuss those as well. But first, let's have a look at what not only what you get in the kit, but some of the details of hardware and the design details, positive and negative. So this is an aircraft we bought with our own money, so we have no affiliation whatsoever with the manufacturer. So this is unbiased review and opinions about this aircraft. One of the first things I noticed with the fuselage was that although it does appear fairly strong, there's quite a bit of flex here. So one of the previous versions of this, I believe the version that did not have a horizontal stabilizer, it was just a plank wing style, but with a fuselage and a vertical tail, had a molded foam across here as part of the structure, and that probably was a lot stronger. Obviously for access, they've taken that away. It does have exceptionally good access. Comes with a very long hatch, which is a little bit on the flimsy side, I think, but is for its purpose, it's fine. It fits nicely. It comes with magnets installed, which honestly, if you're going to be using an autopilot with a compass, you're going to have to remove the magnets and find another latch system or tape or some other way to hold this thing on. But it does come with a magnet, so you can use them or get rid of them. It comes with carbon spars and these thumb screws, which you can use to remove the outer wing sections from this point on. It would appear that they want you to glue these inner joints, although some people put tape on them so that they are removable for service or fishing wires back and forth. You probably will have to remove there's some plates screwed into or glued into the outer, I think screwed into the outer sections of the wing, and you'll probably have to remove those to solder your connections, because there's an electrical connector that gets made when you screw this together for the outer wing servos. They have a good place for the ESCs. They have provision for cooling here with plates that go over this, so that's good. It's important to have cooling for those ESCs. One thing that I found a little bit interesting was they have these. They just provided these plates with the kit, and this is the kit version. But these plates don't really fit exactly any specific place. There's just, you know, they don't really fit at all. So they don't even necessarily line up the spacing with the molded let outs here in the fuselage. So I guess you could, you know, just figure out where you want to put them and use them to glue in there yourself. They do provide a battery strap, which I guess would go around this, so you just have to figure out where that's going to be. Probably want to do that as one of the last steps of setting it up. They provide a BEC, and also it's kind of a power distribution board, and I believe it's a power filter as well. So for your 5 volts for cameras, power a flight controller, power your servo rail. There's not really a way to mount it, although I do notice that the holes line up with some of the holes on the plates. So you could screw it down to the plate on the bottom of the fuselage, which doesn't really seem like a great place for it. The fuselage is quite big. There's plenty of room for battery up here. There's also, for instance, this is not, obviously doesn't come with the kit, but this is a standard Pixhawk, and this will fit inside here without any issues at all. There's plenty of room all the way back, so you could mount this thing back here if you wanted to, although it probably somewhere, you know, in here, and the standard board orientation is this way, so probably somewhere in here, either about there or maybe up as far as this would be appropriate. You want this ideally close to the center of mass of the aircraft, but it's not really critical. So anyway, plenty of room for that. In a moment we'll be taking a look at some of the hardware that we could be using with this, some options for hardware. Now, a lot of people early on with this aircraft noticed that it was, they provide these X mounts. Now these are actually quite nice. They're carbon fiber, they're extremely rigid, lightweight. And they provide screws, 3mm screws for mounting them. And they noticed that they would have to drill out these plastic mounts to get a screw to thread into them. I notice here in this one, as of late in 2022, there's brass, what appear to be brass threaded inserts here. So it looks like that will not be a problem anymore, and we'll have a very secure X mount for the motors. You can mount a variety of motors in this airplane. The motors that they recommend are, I think, a 1200 kV motor with, I believe, a 7-inch prop. And they go, and there's been different prop recommendations, so we're going to have a look at some of the options that we could use. We see a lot of people using drone motors like this with little drone propellers, but we'll be having a look at those options in a little bit. So, flipping this over, you notice the ailerons are pretty sizable. They don't go all the way to the wingtip, which is probably good because it helps protect the aileron from scraping on the ground when you land. They don't go inboard of here because, well, there's a wing joint here, so, but that looks fine. It's looks like they're large enough. You could have quite a bit of fun with aerobatics for this airplane. It's quite a good structure. It's made of EPP foam, and I actually prefer EPO foam for airplanes, although the EPP is going to be a lot tougher. It's not a real lightweight foam. It actually has some heft to it, so if you know, that is what it is, but it's going to help it be more durable for sure. It's the EPP foam that this is made of is a little bit more squishy and flexible, so you're going to have more elasticity in the airframe than you would with EPO, but it's also going to be less prone to scrapes and scratches than it would be if it were EPO. One thing I don't really care for on this airplane, and a lot of others, is this big block nose. I really wish they had some option for a fairing on the front. Thankfully, you can go on Thingiverse and download and 3D print nose. This is one that someone designed for it. Found this on ERC groups on the forum. Now, we'll probably have to cut this back, trace around it, and glue a piece of plywood to the nose, and then mount this with screws to the piece of plywood. But it looks like it'll be a lot better, a lot more aerodynamic. It does seem to fit very well back around this point right here. So if you're not using these and you want them to go away and you want to mount your cameras up top here or even further up, whether it be a pan and tilt or just a fixed camera mounting, you know, they're going to be a lot more protected up here than up in the nose, and they'll probably get a better view depending on the type of view you're trying to get. So that's an option, and that's great to have. So they make a place here for the GPS. They make a cover that goes on it that actually sticks up quite a bit, so a lot of people have modified that to be able to go lower and more flush. Probably a good idea, although it's unlikely to make or break the efficiency of the airplane. Another thing I like, they have these are not carbon fiber, they're quite flexible. I think they're made of some dark resined fiberglass probably. But these are servo covers, so I think they mean for you to be able to transplant servos easily. So they want you to just put the servo in and just screw this cap over it and then have it be able to be taken out, either for adjusting the horn or replacing it, or if it gets damaged or whatever. But if you don't have the exact servo that fits very tightly in here, you'll probably want to either shim up on the bottom and use double-sided tape, or even glue the servo to this plate when you put it in. So there's that. They make they mold in these nuts, these nylon nuts, plastic nuts here, and a place to run a servo wire past the servo to this apparently a hard point on the wing. And we love hard points on wings. That's great. So you could have a physical attachment point as well as an RC control to mount a servo to that. I don't know why you'd want that, or maybe light, or who knows what you want hard points on a wing for, but options are pretty wide open there. So that's great. Like to see that, even if it's not used. When just a note on the quality of the kit and the fit, one of the wing joints, outer wing joints, went together quite easily. The other one was a bit stiff. It seemed like the parts were glued in place and were not very well aligned. We're able to get it together, so if you have a larger vehicle or you're removing just the tail from the airplane for transport, not a problem. You can plug it in, but you probably want to take that apart and work on it a bit, and it appears that's possible if you're taking it apart often. and you're kind of counting on the ease of putting it together and taking it apart. So I always like to see NACA ducts here, so that's great. Plenty of room up here if you do use this chopped off kind of block nose the way it is. Plenty of room up here for cameras. So it's made for, I think, a GoPro 5, 6, or 7. Probably other GoPros will fit in there as well. And a lot of the other smaller action cameras, of course, will fit in there because most of them are much smaller than the GoPro. I would have liked to, and I would like to see this on more airplanes, a nacelle that has the screws for the motor coming in at the back, so you could eliminate this, the X. The X, all it really does is make a much larger footprint for the motor, and it you know, it's less aerodynamic. Although the size of this nacelle is not too bad, and also from Thingiverse, 3D using a 3D printer, someone designed these covers, aerodynamic fairing covers for the motors. So they fit in with slots here to the plastic that's already there. And I suppose you'd have to just glue these in somehow, or perhaps you could use screws to hold them. But it will really drastically help improve the aerodynamics of this nacelle. And this particular version, they've left them open right here, so you know you'll have ram air cooling into the front of the motor, and then there's a place here for plenty of air to exit the motor as well. So probably a good idea. Really want to make sure these are secure, because you know with an outrunner motor you have the motor housing turning in here, and if that were to come loose in flight, the prop is on here, there's no way for this to get out, and it would rattle around and probably cause quite a bit of damage. Hopefully it would just shatter the 3D printed part and expel the parts out the back of the airplane, but it could just rip the motor off too, from the impacts and the vibrations. So kind of want to be careful with that. If there's any doubt if that's secure, probably don't use it. But we printed some up just to show you what's possible, and yeah, we'd kind of like to use them as well. So this fuselage, by the way, we do plan on. I think personally, I'm gonna when I'm finished with this review, of course, I'm going to cut the fuselage in half. It's been glued together in a seam, so there's already a seam there. But I think I'm gonna pull the carbon rod out. I'm gonna cut the whole thing in half. And I'm going to probably design in CAD and laser cut, or maybe I can just hand cut for this one time, some plywood plates to go on the sides of the fuselage to really stiffen that up in the vertical. And I'll probably also make one for one bottom plate that goes all the way back. Now I'll put lightning holes in these and cutouts to keep them light. But yeah, I'd really like to do that. They do have these plates here, and I think these are primarily just to keep wiring from coming in at the top, where I guess the wiring is supposed to come out of the slots here, come down and out through these holes. So yeah, it doesn't seem like the best arrangement, but it's better than nothing. And it seems a little flimsy in here as far as the carbon center tube going through this. It's pretty thin and not very thick, so it should hold up okay. I've heard it seems to hold up for most rough landings. Doesn't seem to be a problem, so we'll see how that works. It would be possible to create some others and double these up and glue them in, just have some more thickness there. They provide with the tails. There's 4 screws that hold the tail on, and there's these nylon inserts in the tail section. So this plugs in like that. Fits pretty tightly and snugly, and then you put screws in from the side. Now, the distance that these are apart, I kind of have a little bit of issue with. And it may be okay, and I know a lot of people just glue the tail on. That would be perfectly fine. but I would have liked to see, you know, maybe less of these, or you could have the same amount, but I'd like to see at least one screw on the top and bottom as well, you know, so that it's more secure. But again, haven't tried this yet, so, you know, it's kind of hard to judge. This is a spot I believe they have for an antenna, for a kind of T-style antenna, which would come out and then be mounted vertically. And then this, I guess, should be an aerodynamic fairing, although it's not going to help very much. But it would kind of help locate the antenna and hold it there. You probably could like tape it to the side of the fuselage for the bottom part of the dipole for your control system. A lot of long-range systems are like Crossfire, or a lot of the ELRS systems are using an antenna that would mount there. The tails both have a hatch on the bottom for access, and I believe they want you to mount the VTX back here. So you probably break away this section. Again, there's magnets. And then on the top, on both the tail sections, there's this little plywood thing for mounting, I guess mounting an SMA connector where you screw on your, I guess, circular polarized antenna. I think they want you to use 5.8 gigahertz because a 1.2 would be kind of really large. I'm kind of more in favor of using the lower frequencies and mounting it maybe inside the fuselage. As we know, foam and a lot of the other materials we're using here are pretty much RF transparent, so that shouldn't be a problem. And I've had a lot better success with the lower frequencies. The control horns, a lot of people have had a little bit of an issue with this. They push through and then have a slide-on ratcheting stop on the other side, and it just goes into foam. It's a relatively small pad, so a lot of people have had issues with that moving and working in there. Might be a good solution to, you know, let away the foam a bit, or just glue on top of the foam very securely, of course, a kind of larger plywood pad, and then screw a more conventional control horn to that with actual fasteners, so that it is really solid on that control surface. Not a real big rudder, but again, it doesn't have a large wingspan. There's not a lot of adverse yaw you'll be having to contend with, so that size is plane you'll primarily be turning it with the ailerons. The rudder will be just to coordinate those turns a little bit, and probably not going to be needing a huge rudder. Size of the elevator looks great. A lot of airplanes like this have undersized elevator. This one looks quite big. One of the issues with that I see with the tail, now I think they expect you to glue this on. It has a kind of tongue here. The servos mount, I don't know why they have two places to mount a servo, but there they are. So it's meant to, I think all these surfaces be glued and then it be put in, kind of snaps into place there. You want to hold it while the glue dries, and that kind of becomes one piece. For transport reasons, the rest of this would kind of fit back in its packing box, except the tail all glued together probably won't. So I was kind of interested in putting in maybe a plywood plate in here somewhere and having a screw maybe from the bottom to hold this all together. However, if you do that, there's going to be a lot of flex here, and you might need some additional plate to go over here with screws in it, and that kind of gets messy and complicated and too many screws. So the V-tail doesn't have that issue. It's a lot more robust, and it's easy to notice that happen to notice that if the V-tail were glued together, it would kind of fit like this in a box with the fuselage and center wing section. They kind of nest with each other. There's this strake that they give you to glue in. It would be nice if there was something down here as a skid, so this doesn't get completely tore up again, there's a place for your VTX in there, and the rest of the tail, the rest of the fuselage is kind of the same. These, there's quite a bit of surface if you're gluing this on, but there's really no mechanical way of that these tie together, so you're really relying on the foam and the glue to hold this together, which appears to be fine. They're not very long, and I'm sure it's fine. But it's kind of a shame because they do have some carbon fiber molded into, rods molded into these, so it would be nice to see those tie into the fuselage, even at the rear of the tail or up a little further, and tie in somehow to each other. That would be spectacular. They haven't done that, but again, it doesn't really appear to be a problem. The control surface size on the V-tail is quite small, it appears to me. So you probably need close to maximum throws to get a reasonable performance, especially since it's a V-tail. Moving both of these up is kind of not the same as moving a comparable sized, combined sized elevator up and down. So I'm going to guess that this V-tail is not as aerobatic and maneuverable and doesn't have the same control authority as the conventional tail, which is probably why people are using the conventional tail. Along with that, when you use a V-tail, the angle of attack and the effective angle of, we'll call it toe in and toe out, of the two tail surfaces changes as the angle of attack changes. It actually goes to a toe-in configuration or toe-in geometry as the angle of attack increases, and then goes as the angle of attack decreases, such as at high speed, where the wing's making a lot of lift and the tail is up a little bit and actually making more downforce. Or during, it actually goes out. So there's some other aerodynamic issues of the V-tail which may make it a little less suitable to smooth flying in some flight speeds and some angles of attack. So, but we'll see how it performs. If it's large enough, it could be fine. But we'll just see. It's really like the option though. V-tail is also very visually striking and attractive, and again practical for quite a few reasons. So now down to that issue with the wing chord. Now, one thing with any aircraft that has uses any wing, regardless of whatever the chord of the wing is, as a lot of times, we put the center of gravity typically between 1/3 and 1/4 of the wing chord forward. So why is that? Well, the middle of the wing area is right about the middle of the wing, right? So we might expect the lift to be created at the middle. You drop a sheet of paper, and the piece of paper, the overall drag or lift created when it's falling is right about the middle. Well, with a wing moving forward, it's a little more complicated than that, and it's kind of a long explanation. But as the wing increases in angle of attack, the lift may be back toward the midpoint, probably a little further forward than the midpoint. But as the wing increases in angle of attack, so either during a G maneuver or just at a low airspeed when the nose is pitching up, the center of aerodynamic pressure, which we would also call the center of lift, so the lifting force, will actually shift forward. There's this bubble of low pressure on the top of the wing that actually shifts forward as the wing pitches up. So if the center of gravity is in faster forward level flight is just in front of that center of aerodynamic pressure, all is fine and well. As we slow down the airplane or do a hard banked turn, the center of pressure can actually move in front of the center of gravity, and the airplane will basically swap ends. So you get it's also it's something often referred to as a stall, but it's more like just falling. In this particular case, it's not actually technically a stall. So airplanes like this, this is not necessarily a fatal problem, in but it requires that the center of gravity be much farther forward. And if we look at this airplane, the center of gravity is basically it's I don't know, about 75% or more of the way forward. So these large chord wings will have quite a large movement because the movement of the center of pressure is mostly correlated to the length of the chord. So you get a big thick wing with a large chord, you're going to have a lot of movement in the center of pressure. You need to keep moving the center of gravity forward until you can fly it at a high angle of attack without the center of pressure moving past the center of gravity. So that's why you'll see these airplanes have a fairly forward center of gravity. This is detrimental to the efficiency of the airplane because the tail has to create quite a bit more downforce, which is counteracting the lifting force of the wing and decreasing the overall effectiveness of the wing. You're paying for that lift in the form of aerodynamic drag, and then you're canceling it out with the tail. So, of course, if you've watched the channel quite a bit, you're familiar with a lot of the airplanes that we've designed for utility and efficiency on this channel, and you'll know that almost all of them use quite a high aspect ratio wing. There's structural challenges to that. It has to be built very strong and light in order to still perform well, but you do get that performance back plus a lot more in terms of efficiency. So we probably don't expect this to be a super efficient airplane, but very transportable. And here's an extra benefit of this type of airplane. Since it does have a large wing area, that wing area is maybe not as effective as a larger span. The extra wing area, it's acting on a smaller section of air and trying to make more lift out of it. Another reason why it's not as efficient. But it can make quite a bit of lift, even if the efficiency drops off an awful lot at the higher angles of attack. It's going to really require a lot of power. It's going to have a bad glide path at those high angles of attack, very bad. But if you're just using that high angle of attack and low speed flight for landing, probably don't need flaps. So eliminates a little bit of complexity and makes the aircraft structure more robust and lighter. So there's those benefits. So you'll see these airplanes being used a lot for short to medium range flying. You'll see them being used for some sort of long range flights, but the efficiency is very limited inherently because of the design. So for these type of airplanes. So we just have to be conscious of that limitation and know that, but also understand the other kind of benefits that it gives us, mostly in terms of practicality. So if you're putting this thing in a kind of maybe a large backpack or a carrying case and hiking with it and bringing it different places, transporting it, it's great for that. So that's kind of what we wanted this airplane for, to be able to take it everywhere. Also, being able to take off and land and being robust and be able to kind of stuff it in bushes on landing instead of requiring an actual runway, and being able to hand launch it. That was a real benefit from an operational standpoint. So should be really handy to take places, get footage and explore areas maybe that are not super large, but really don't have a landing and takeoff landing site that's appropriate for larger aircraft or aircraft that are higher performance. So probably maybe be able to catch this thing. You probably want to watch out for the props, but there's, you've got a fuselage you can grab onto if you manage to fly it toward yourself. Do it at your own risk. So anyway, that's a look at the airplane. How about we have a look at some of the hardware that we might be using for it. These are some servos we like. They're 3302 Emax. These particular servos, they're an analog servo, which I like for FPV. They have quite a large shaft, so there's going to be very minimal play, or if none at all, in the from the horn to the shaft. They're very small, so they're smaller than most micro servos. This is, for instance, there it is fitting in there. So it kind of will fit in the space. That's really handy. If it's that larger pattern. Where they're smaller is how thick they are. So they're the thickness of this. So we'll probably have to put a shim or something back here to use these. The torque is quite good. They outperform a lot of servos that are larger than they are. The speed's pretty good. The price is somewhere in between the cheap servos, very cheap nylon gear servos, or even some of the ultra cheap metal gear servos, some of the other different Emax servos, which we don't like, and the higher end servos like some high-tech either carbonite gear or metal gear servos. And these do have metal gear, so lightweight, pretty powerful, fast enough, and just the right price point. So really like those. Of course, standard Pixhawk could also use, they haven't made them for a while, but if you can get a hold of them, a Pix Falcon or a R15 Pix, what is it? Anyway, some of the other smaller flight controllers that either run ArduPlane natively or can be flashed with ArduPlane. So a lot of people are using these drone motors, or similar drone motors for these airplanes. And these motors almost always, they're running higher KV, they're turning smaller props. They're not very efficient compared to most of the motors with the lower KV that are meant specifically for airplanes. So if you plan on using these high power drone motors, plan on going with a LiPo battery, not a lithium-ion battery most likely, and don't expect really long flight times from them. They're, maybe get a lot of thrust, they're going to make a lot of noise. Same goes for three-bladed props versus a two-bladed prop. Now, a lot of the specs and recommendations for this airplane are recommending a 7-inch prop. And with a 7-inch prop, as you can see, you kind of have a chance of landing it without damaging the props too badly, although it looks like they will touch on landing, 7-inch. So that's kind of where they've gone to 3-blade. They can get a bit more blade area with less diameter. They fit very well, a lot of clearance here. But I would really prefer to have a larger propeller on it. So that's a 7-inch. This is a 8-inch propeller, so a little bit more pitch, so it should be a bit more efficient. The drone propellers, for instance, a 7x4 that are made for freestyle or racing drones, it's really not enough pitch to be efficient in forward fixed-wing flight or any at forward flight speed. You want a little bit more pitch. This is, I think, an 8x5.5 or 5.6. So a little bit better. Still a 3-blade, so not as efficient as a 2-blade. So that's another option. Could probably use that with a bit lower kV motor to get some more efficiency. But what I would really like to try is in an airplane propeller, for instance, a 9x6. Now, sometimes you may not be able to find in your area an APC 9x6 in the same brand with counter rotating, and we do recommend counter rotating propellers for all twins or multi-engine aircraft. The direction it would be best to rotate would be inboard at the top, and there's basically one main reason is that the torque P effect, slipstream effect, and gyroscopic precession from inboard turning propeller helps counteract the lateral offset in the thrust if you were to lose a motor. So you won't have one motor that's critical if you use counter rotating and turn them in at the top. For instance, this is a Gemfan brand propeller, 9x6. The design is basically a copy of the APC, so it's a different material, slightly different color, but okay to use together. No reason why they couldn't be used together. So this is a Gemfan, this is an APC. So there you go. As far as fitment on the airplane, yep, they fit. 9-inch propeller fits. It's got about a 1/2 inch, maybe 12-13 millimeters clearance to the fuselage. Not a lot, but it does fit. It's not going to rub. So 9-inch prop would be about the max. Now you're going to have some issues on landing, so a lot of people would be setting the brake maybe to try to help that. There's also would also be possible to add a skid, maybe even one with a wheel integrated into it to the bottom of the airplane. Wouldn't be a bad idea anyway, so that to keep the bottom of the fuselage up off the ground on a rough landing and to kind of soften the blow from landing in very rough or gravel or rocky surfaces. And if you 3D print that part and have a wheel that you can replace or change, or when it gets worn or broken, that's kind of a sacrificial part that you can keep replacing whenever you need. So they do provide a skid plate with the airplane, a little plastic one, but it doesn't go back very far, so it's only going to protect back to about here on the airplane. So considering you're landing the back of the airplane usually first in a nose-up configuration, that's all going to get scraped up. Of course, a lot of the weight's up here from the battery, so it's going to help a lot, but probably not ideal. I don't think it's the ideal solution, so we'll probably be trying something different, like the skid with the built-in wheel. So anyway, the push rods seem a little flimsy. This is I'm nitpicking here, but these are ball link, so they kind of go on the side of the control horn, and they'll have a little bolt through it. When you push and pull hard on them, they will tend to, because they're mounted on the side, they'll tend to twist the control horn. So that may be a little less than ideal. Now you could bypass that by using this Dubro part. It's a push rod with a clevis, and that would span this and push directly on the horn. So that would be a lot better. They make these, they're kind of economical, and they work fine. You will need to put a Z-bend in this, so you'll either need Z-bend pliers or make a bend that goes out and then sideways. It's a lot easier to do that with a pair of pliers if you do not have a pair of Z-bend pliers. The other option you could do is go up to like a 440 stainless threaded rod and use these other snapping locking clevises. They have a little brass pin, so there's nothing to rust here. But you would have to use one of these on each end of the 440 rod, one at the servo end and one at the control horn end. But that would be a lot better. So those are some kind of upgrade options. Might add a touch more weight to the airplane. It's probably not a big deal, but you'll have a lot better you'll have a lot more robust control linkages. But I'm sure the stock ones work, but I'm sure that can also be improved. Assuming you're using RDplane or some other autonomous system, a lot of times what can happen with speed controllers, you want to be careful what speed controller you use. And we may do a future tech episode on this, but what can happen, a lot of them have a low voltage cutoff. And what'll happen is the airplane if you're using a lithium ion battery and you haven't either turned off or turned way down the low voltage cutoff in the ESCs, your airplane can be flying around autonomously, and the next thing you know, one or both motors quit. And they'll quitting because the ESC is protecting the LiPo battery, which you don't have necessarily. Even if you have a LiPo battery, you don't want to lose the aircraft and have it not return to you just because the battery might be getting drawn down a little too low. These ESCs were meant for line of sight flying with airplanes that could glide, sport planes that maybe motor gliders that could glide back to landing when they chop power to the motor. We really don't want that. This is a solution, one solution for that. These are Castle ESCs, they're quality. And this is a multi-rotor ESC. They have these, actually I believe for sale on their website right at the moment in their clearance section for I think around $16, $17 plus shipping and each. They're very good quality. They handle ripple current very well, and the low voltage cutoff I think is set to like 6 volts from the factory. The reason I like these is they don't require any additional setup from in software or anything. That you can just plug and play. You will have to calibrate your endpoint, or well, you'll have to perform a calibration on them to get the PWM range correct for RDplane. But other than that, there's no setup for them. No features you have to turn on or off to make them work properly. Low voltage cutoff is very, very low. I think it's 6 volts, so that works. Another option for a bit less money are these GeForce. They're labeled Simon K 30 amp. Not all Simon K ESCs are the same. A lot of the Simon Ks have low voltage cutoff like we talked about. These particular ones, the ones we've tested, do not. So these are a good option as well. We plan on using quite a few of these, and the cost is right. I actually like this a little bit better because for some reason, there's nothing wrong with the Castle, but the startup is a little rough on the motors. They start up reliably, and when the motors are running, the airplane's in the air, you can hear the motors. The motors are a little bit louder. I don't know if it's the timing or the way the pulse is generated or the way the power is filtered, but I'm sure they're very good quality and they've been reliable. But these Simon K ones, they're cheaper and the motors run quieter, which I like. So the startup's super smooth as well, much smoother than the Castle. Again, for reliability, it doesn't matter. I don't really know which is more efficient. Haven't been able to tell any difference between the two. But until I know different, I'm going to be trying these on more airplanes coming up. So that's that update. So anyway, we hope you've enjoyed this episode. We hope you learned something. And we also welcome feedback. So if you have experiences that add to this, put them in the comments down below. If you have a difference in opinion on any of these things, go ahead and put it down there. We'd be happy to discuss that. And have a nice day. Thanks for watching. Don't forget to subscribe and give the video a like. And check out our website as well for our more advanced, unique projects that we have going. So thank you. Have a great day. Bye.